All right, let's dive into something that's probably going to mess with your head a little bit, in the best way possible. We're talking about quantum entanglement. It's this idea that two objects can basically be a single entity, no matter how far apart they are. Yeah, it forces us to completely rethink what things like distance and separation even mean. I mean, just let that sentence sink in for a second. It gets right to the core of this whole thing. It's totally counterintuitive, and it suggests that maybe, just maybe, the idea of a separate thing is just an illusion our brains create. Okay, so what on earth does that actually mean in the real world? To get it, we really need to unpack the phenomenon behind the quote. So let's break down what entanglement really is. We're going to start with the absolute core concept. And this is the point where our everyday, common sense view of the world just kind of starts to fall apart. So, at its heart, entanglement is all about a deep, fundamental connection between particles. Think of it like you have two coins that are magically linked. Once they're entangled, you can't really talk about one without talking about the other. They're basically two halves of the exact same story. And here is where it gets genuinely bizarre. Let's say you measure a property of one of these particles, like its spin. The result you get is totally 100% random. But, and this is the key, the very instant you get that random result, you know exactly what the spin of its partner is, even if that partner is on the other side of the galaxy. Their outcomes are always perfectly, instantly correlated. And here's the real mind-bender. That property you measured, it didn't even exist a moment before you looked. And let's be super clear about this. This isn't some glitch in our equipment or because we're missing some information. Nope. All the evidence, everything we've tested, points to one crazy conclusion. This weirdness is baked into the very fabric of reality itself. Now, as you can imagine, an idea this strange, this counterintuitive, it really bothered some people, and it especially troubled one of the greatest minds in all of history, Albert Einstein. He was absolutely convinced this couldn't be right. He actually came up with the perfect name for it. He called it spooky action at a distance. For Einstein, the whole idea of one particle instantly affecting another one light years away, it just broke a fundamental rule of the universe he held dear. Nothing can travel faster than the speed of light. To him, it sounded like pure magic. This chart really lays out the battle lines perfectly. On one side, you've got Einstein's local realism. That's just a fancy way of saying, hey, objects have their properties set in stone, whether we look or not, and nothing can communicate faster than light. But on the other side, you've got entanglement, which says properties are only created when you measure them, and that connection is instantaneous. This wasn't just a minor disagreement, it was a fundamental fight over the nature of reality itself. So, who was right? Was it Einstein and his common sense, or was it the spooky rules of quantum mechanics? You know, the amazing thing is, this wasn't just some philosophical debate, it was something science could actually test. Physicists came up with these incredibly clever experiments based on something called Bell's theorem. These tests were designed to check if the particles were maybe following some kind of hidden, pre-programmed instructions. You know, like they had a secret rule book from the start. They were built, in essence, to see if Einstein's version of reality was the correct one. The results came in, and they were conclusive. Decades of experiments, each one getting more and more precise, all showed the same thing. Nature does not play by Einstein's common sense rules. That spooky action at a distance, it's real. On this one giant topic, the greatest physicist of the 20th century was simply wrong. Okay, so if this connection is instantaneous, does that mean we can build some kind of faster-than-light telephone? Could we send messages to another star system in a blink? Well, the answer, maybe a little surprisingly, is no. And it's really important to understand why. The whole reason it doesn't work is randomness. That's the absolute key. When you measure your particle, the result you get is completely unpredictable. You can't force it to be spin up to mean yes, or spin down to mean no. And if you can't control the outcome on your end, you can't use it to send a message. All you can do is observe a correlation that was already there. So the best way to think about this is to stop thinking about two separate things communicating. They're not. They're more like one single system described by one single piece of math that just happens to exist in two different places. It's not about sending information, it's about a shared existence.
And once you start thinking in terms of the shared existence, man, it opens up a whole new way of seeing the entire universe. It has huge implications, not just for physics, but for technology and even for philosophy.
Now this is a pretty radical thought. What if the universe isn't really a collection of things at all? What if, at the deepest, most fundamental level, it's actually just a massive web of connections and relationships, and the things we see are just patterns in that web?
And hey, this isn't just some philosophical daydream. We are literally building technology based on this principle right now. Quantum computers, they don't just store ones and zeros, they encode information in the complex, entangled relationships between particles. And that's why they're so powerful. They don't have to simulate reality's weird rules, they're physically built out of them.
So let's bring it all home. What does this deeply interconnected, kind of spooky reality mean for you and me? What does it say about our place in the universe? I think the final takeaway is a pretty profound one. That feeling we all have of being a distinct, separate person cut off from the rest of the world, it might be a really useful illusion for, getting through the day, but at the fundamental level of reality, that separation just isn't there.
This really means that when we look out at the world, we're not just passively watching a movie that's already been filmed. The universe is a sea of possibilities, and our very act of observing it, of interacting with it, helps make one of those possibilities real. We're not just spectators, we are active participants in the unfolding of the cosmos.
And so that leaves us with this one final, massive question to just sort of chew on. If the universe, at its very core, is nothing more than a network of relationships, then what does that make us?